Thanks, Matt. I appreciate it. Thank you for having me here today. As you mentioned, my name is Tiffany Shaw. I'm the Vice President of the Industrial Water Group at Haskell. So I wanted to start off with a little bit about what we're going to be talking about and then about myself. So my topic was water, our most precious resource. And like Matt said, there's a few things that could be considered those top things that without it, we just can't survive. A little bit about Haskell. We're here in Jacksonville. Haskell was founded in Jacksonville. Headquarters is located here. We do a lot of things for the city. We built the JAGS practice facility right next door. We just completed that this year. So there's all facets of what Haskell does. My piece is the water market. It is the fastest growing market in Haskell right now. So I'm excited about that. It's definitely something that's on the forefront of communities and companies nationwide. We do other things as well. We do food and beverage manufacturing, pharmaceuticals, hospitals, and kind of our mantra right now is we build things that matter. It matters to our community, whether it's water, snacks are important, beer, wine, and spirits, all of the different things that impact human life. So a little bit about Haskell and how my focus is within the company. So to introduce myself, I did go to Georgia Tech, so another Georgia Tech graduate here with Matt. I'm a civil engineer. I have DBIA certification, which is basically a delivery model for our customers. Municipalities use it as well. It means we do the design, and construct it, and commission it. So the whole turnkey package is how a lot of people like to think of it. And then an ENVSP is a certification around water specifically for sustainability. So many of you have probably heard of LEED buildings. That is easier for a big structure that has lights that can turn on and off, but cleaning water is obviously a very energy intensive process. So you're going to have to use power and separation to get that accomplished. So it's just a different metric that allows you to show you're the most sustainable that you can be while accomplishing the goal. And then I am a professional engineer in Georgia, Florida, and North Carolina. So as we get into it, what is the role of design? Design and engineering plays a crucial role as we move forward with sustainability. In particular, how do we think about the future? Are we designing for just today, next week, next year, or are we looking more of a long-term solution, for generations to come? And engineers are really at the forefront of that with the governments and companies that we service. There's a balance. It's not an endless capital source, but how do we manage that give and take to get the most sustainability we can, design it in to set everyone up for success in the future? So the main areas when you think of how engineers are contributing to sustainability and design is going to be through the sustainability, a lot of it in healthcare, AI we just heard about, and then cleaning the water and wastewater. So those are the main areas right now where design is really leading the way for what our future looks like. So water, one of our most critical resources. It's definitely one of our basic survival needs. We can only survive 3 days without water, and shockingly still 40% of the people do not have access to clean water. So when you think about that worldwide, we're very fortunate to be able to, turn on the tap, it's clean, you flush your toilet and nobody thinks about it except for, unfortunately, me and a small group of people who have to deal with it. But definitely, worldwide, it's a much larger problem. So we're gonna focus on, what we see here in Jacksonville and how it's impacting these technologies, much like most technological advances, are driving those costs down so that they can be implemented in a much larger global solution. So why is it important? So it's something we definitely all take for granted, but when you look at treating public water and wastewater, the most basic thing, when you look back at how the history started, it was public health. People were getting very sick, in the early days on how sanitization became important, so they had to get that waste away from the people, away from the cities to be able to protect human health. Safe drinking water, again, if you're waste isn't managed properly, you're contaminating your drinking water and then impacting your physical, mental, and well-being. When you drink that water, you get sick. It can cause a spread of disease. We obviously want to protect the environment. Here in Jacksonville, there's the river, the ocean. You can't just dump things into the river. The saying used to be, dilution is the solution. Well, kind of, but not really. So, that's kind of an older way of thinking, and it's definitely impacted the animals, the wildlife, all of the domino effect of not treating the wastewater properly. Industrial processes, again, so when you buy something from the store, whether it's that bottle of water that goes in your food, it needs to be treated to a safe standard to get to the public and for consumption. And then agricultural use, same thing. If there's no water right, harder food supplies drives prices up. All of those things go together. And water scarcity. You hear a lot, we talk about all the growth in Arizona, for instance. Arizona's a desert. They don't have a lot of water, but we're having all these companies move there. So it's driving things like aquifer recharging, as well as deep well injection for wastewater. So balancing that resource with the demands where the water exists has definitely become something that's very important. So how are we doing it? So as time has gone on, the requirements get stricter and stricter for cleaning wastewater, so the technology has improved. Some photos here, the bottom 4 photos are a project we are doing in Jamaica for a rum distiller. This is an evaporator. It's 90 feet tall, so what comes out of when they make the rum is it's called dunder. They treat it because they were spraying it on their fields. Well, it's too strong and bad for the environment. So now they're going to dewater it, use part of it for animal feed, and then use the clean water for irrigation on the fields again. So it's impacting not only locally, but every market you can think of. The water cleaning and wastewater reuse is definitely becoming a topic. The picture on the right is called an MBR, so it's a membrane. Basically, it's a little tube that the water's sucked from the outside up through the inside, and the size opening is 0.2 micron, so itty bitty bitty, removes almost all the contaminants through it, but it's very energy intensive, and it's definitely what most municipalities use to filter their water. So as technology has advanced, it's allowed us to become more efficient and get those requirements down lower and lower and lower of what goes back into the environment when it's treated. So how do we have sustainable water practices? Basically, when we look at the integrated water resource management, it's all related, right? There's only so much water on the earth. We have to reuse it, we have to clean it. I know this is going to be bad news for all of you, but you're drinking someone else's wastewater. It is what it is, but we don't like to think about that, right? We like to think about it being fresh and clean, but it's definitely important that we look at how this cycle works, how we're using it, how we're being good stewards of it, how we clean it and get it back into the environment. So I wanted to show just a quick time-lapse video of something that we have built. And I'm at a loss with 2 buttons, so I'm hoping somebody has a button somewhere that'll make this play. But this is gonna be a time-lapse video showing a project we did for a pharmaceutical company in North Carolina. There we go. And it's gonna show, basically they had to do additional treatment to their wastewater before it could go to the town because the town had gotten stricter limits from the state. So basically what we started with in June 22, they were very kind. They gave me a stormwater detention pond to start with. They said, here, you can have this. So we were able to utilize this recessed area in the ground to drive piles. So this is to make it structurally sound, deep foundations under there, and we're gonna build, very quickly, you're gonna see us build a big concrete tank for the wastewater treatment. So you can see here, as they're building, should snow in a minute, the walls will come up and we'll start to do this water-bearing structure. So this plant is to treat 2 million gallons a day of flow. So they produce, this company produced some vaccine bases, so like the plasma and the base that go in a vaccine. So they have to pre-treat before they can send it to the sewer. So we built this wastewater system for them here. And this will allow them to get below their effluent discharge limits and allow the city to get in compliance. But this project is about a $30 million project. It took us just about 18 months to complete. And this is just one manufacturer, one industry, just to give you a sense of how much money corporations are having to spend to treat their wastewater, to produce their products, to protect the environment. And as we move forward, the the rules are getting stricter, but companies are also wanting to do the right thing. They want to be sustainable. They're going to start reusing their water. So after they do this level of treatment, it's really clean water. They can implement, one more piece of equipment and maybe utilize it for not necessarily in their product, but non-contact. So boilers, chillers, cooling towers, those sorts of uses that are non-contact. So we end up building a building here on the side that houses all the equipment and then one more tank in the front. But this just gives you a scale of, this isn't a little thing that plops in a building. It's a very advanced, sophisticated treatment system. So once the byproducts of this waste and wastewater treatment come out, they're dewatered, and those solids have to be moved to the landfill. So there is still a waste product that has to be dealt with in the most sustainable way possible, but it is drastically reduced by the advances in technology. And I think we just have a couple more seconds, and then we should be able to move on. And then this was the project I was mentioning. As we move forward in design, it's come a long way. We do lots of 3D renderings, lots of modeling. It allows owners and reviewers to see what their facility is going to look like. So this is the project in Jamaica I was speaking about. And then this last spot here is, I know some of you have seen Disrupt Tech. They're part of the Haskell company here today, and they help us. They do a lot of clash detection. We do a lot of modeling, a lot of overlays. And as you can see here, some of the technologies allow us to take a look at the design and be in the field, and you can walk and see where you are in the design, what the field's gonna look like, and how. I don't think I get that one to play because it's a link. I didn't embed it. But it allows you to really immerse yourself using that technology to design as best as you can and avoid a lot of challenges in the field. So there's a lot of things that are exciting going on with water and wastewater, not only in the private side, but JEA is spending millions here locally doing new wastewater plants, water treatment plants to support the growing population, as well as the increased environmental standards. Thank you.